Hi, my name is David. Today we're going to do number 101, symmetric tree. This is an easy level problem on LeetCode. I want to solve it in JavaScript. So we're giving a root of a tree, and here's one example, and we want to see if it's symmetric or not. So in this case, symmetric is think of is folded in half or like a mirror, and it's a reflection. So one is equals to itself, two, this is equal to two. And in this case, the three here goes to 3 here, and a 4 here goes to the 4 here. So we can use a recursive approach to solve this problem. And what we can do first is let's break it out. So we can look at this one first, because when we do call the recursive function, we're going to compare these two and then the nodes, the left and right of them. So we can look at the root first. So if root is null, we return null. So if root is null, we return true. And the function. If root is null, return true. And we're gonna assume here that I don't know if they put it here, but if root is null, we return true. If there's nothing there, it's symmetric. So what we want to do next is that we want to call our recursive function. So call recursive and taking in the root dot left and then root dot right. So this is when I'm going to start comparing things. So inside of this function, what we want to check first is that we want to check if both of them are null. We traverse through the entire tree and get to null, and we haven't found a case to make it false. We return true. So return if left and right are both null, return true. And then next we can look at what will make it false. So if only the structure of this tree, so if only one side of it is null while the other isn't, we return false. If one side of tree is null while other isn't, return false. And then we can compare the values of it. Compare if values aren't the same, return false. And then now we can call this function recursively. Return, if we don't hit any of those returns, we return calling the function again. So return recursive function. And we're going to call it twice. One on the left side and one on the right side, and that the chain will keep going. And this will take in left dot left. And in this case, this 3 is going to compare to this one. So it's going to compare to right dot right. And then let me move myself. And we're going to call it again, but with the other function. So left dot right, and then right dot left. Great. So there's 4. It's going to compare to this 4. Okay. So to put it in code, first we check the root. So if root is equal to null, we just finish there. Return true. And next we call our recursive function. So return, and let's just call it compare left, right, and it will pass through root dot left and then root dot right. Now let's define our helper function here, const compare left, right, and we're going to turn into left and right. And inside of here, first, let's check if they're both null. We traverse through all of it and they're both null at the same time, so return true. And it goes up the call stack as true. So if left doesn't equal to null and right doesn't equal to null, sorry, when both of them equals to null, return true. And now we can check the structure of it. So if left does not equal to null and right does not equal to null, return false. And I can put this all, combine these in one line, but I'm just writing out to help communicate the code. So now if left equals to null and right doesn't equal to null, return false. And now we compare the values. And then we have to do this first, or else we're going to compare the value of null, and that is going to break the code. So if left.val doesn't equal to right.val, return false. Wait, let me create some space. Okay, now we call our function recursively again, return. It doesn't hit any of our cases. It doesn't go to the end of it. We don't find a false instance. We keep calling this function. Compare left, right. And then we have to call it twice. So left dot left, right dot right. So command 3 here. And then we do and. Just copy this again. But this time we're changing left here with right, and then right here with left. Great, and that's to do it. Nice. So with the time and space complexity, since we're iterating through the entire tree, it's going to be O of n. And since we're doing a recursive approach, creating a function for each node, we do a space complexity of O of n as well, where n is the number of nodes. So that's how I solve this problem. Thank you so much.